All right, so in this video, we're going to look at just a review of right triangle trigonometry. So we're going to go kind of fast just because this is probably the third time we've been looking at this. And way back in geometry, we looked at SOHCAHTOA, and what that means is that the sine is the opposite over hypotenuse. So that is the SO part of SOHCAHTOA. The cosine is the adjacent over hypotenuse, and the tangent is the opposite over adjacent. So SOHCAHTOA is a way that we just kind of remembered using a mnemonic device what sine, cosine, and tangent represent. So we're going to review what this all means here, but just kind of wanted to refresh your memory on that whole SOHCAHTOA business. All right, and if this is the first time you're seeing this, then real briefly, sine, cosine, and tangent are just ratios on a right triangle. And so sine represents the opposite divided by the hypotenuse, cosine the adjacent divided by the hypotenuse, and tangent is the opposite divided by adjacent. And that all probably sounds like a foreign language to you. I'll explain what those mean here right now. So let's first refresh our memory and identify which one is opposite, which one is adjacent, and which one is hypotenuse. So if we are dealing with, let's grab a new color here, we'll do red. With this angle right here, this is called theta. I'll do this over here. It's a Greek letter, and we use it typically when we're talking about angles. So theta is that angle in the lower left of this right triangle. And so the opposite side from theta is going to be the one across from it. So this side right here that I'm highlighting in red is going to be called the opposite. The hypotenuse is always the one across from the right angle. So that's going to be the hypotenuse. And the adjacent, this means next to. So Apple Valley is adjacent to Rosemount. It's adjacent to Egan. Those cities are next to each other. So next to would be the side that is next to theta, which would be this one. Now, the hypotenuse is also adjacent. It touches the angle, but since it's the hypotenuse, it's not considered the adjacent side. Okay, what if we switched where theta was? And so now theta is up here in the upper right. So now the opposite is the one across. So the moral of the story is it always depends on where you're dealing with, which theta you're dealing with, or which angle you're dealing with. The hypotenuse never changes. It's always the longest side, and it's always the one across from the right angle. And then the adjacent would be the one next to theta. So basically, make sure you identify where your angle is. In this case, it's that corner with a red dot, so the opposite is the one on the far side from that. Okay, so what we're going to do is identify the sine, cosine, and tangent of theta for this triangle. We have a right triangle where the two legs are 5 and 12, and the hypotenuse is 13. So what you first want to do is identify which side is the opposite, which side is the adjacent, and which side is the hypotenuse. So hypotenuse is typically the easiest one. That's the longest one. So that would be the 13. And then the opposite side is usually the one I go for next, and that's the one across from the angle we're dealing with. So I'm going to just label opposite there, and then adjacent is the one next to that, so that's going to be the 5. Okay, so if you recall back to when we first started, we did the SOHCAHTOA. That means that sine is opposite over hypotenuse, and so the opposite is 12 and the hypotenuse is 13. So the sine of theta is just 12 over 13. It's just a fraction. Whenever you talk about the sine or cosine or tangent, you're talking about a ratio or a fraction. Okay, cosine is adjacent over hypotenuse, so that's going to be 5 over 13. And then tangent is opposite divided by adjacent, so 12 over 5. And that's it. All you got to do is figure out which side is the opposite, which side is the adjacent, which side is the hypotenuse, and then label the trig identity, the trig functions from there. So this will come up. I didn't change the numbers at all. It's the same triangle, but you know the numbers will change on different triangles. But it's gonna, this one I'm saying identify the sine, cosine, and tangent of each angle, each acute angle. So let's start with A, and that one we pretty much already did. That means that theta is up here at A. So 12 is going to be the opposite, 13 is going to be the hypotenuse, and 5 is going to be the adjacent. This is, you know, what we just did. I'll write down so toa again, just so we have that handy. I always write that down on all my worksheets so I remember them. Sine is opposite over hypotenuse, so for sine of A, it's 12 over 13. Cosine of A is adjacent divided by hypotenuse, so 5 over 13. And tangent of A is opposite divided by adjacent, so 12 over 5. Now, here's what happens though. When we move to, I'll switch colors so we can see that we kind of transition. When we move to C, now what's going to happen is theta is going to move as well. So theta is now at C, and that's going to change our opposite and our adjacent. Now the opposite is 5. The hypotenuse hasn't changed, but the adjacent is the one next to it, so 12. So the sine, remember that's opposite divided by hypotenuse, that's going to be 5 divided by 13. Cosine is adjacent divided by hypotenuse, which is 12 divided by 13. And then tangent is opposite divided by adjacent, which would be 5 over 12. So the moral of the story here is make sure you identify the opposite and adjacent and hypotenuse based on which angle you're dealing with. And we don't do this with B, you don't do sine, cosine, and tangent with that 90-degree angle. All right, so the next and last thing for this video is solving for a missing side. And so this you're going to have to use a calculator, and I have one ready to go here. But here's the steps. 1, identify the two sides you're working with. Then step 2, which trig function are you going to use? 3, set up the equation, and 4, solve using a calculator. So here's what we're going to do. Here's our theta right here, is 25. That's the angle we're going to deal with. So x is the opposite, and 14 is the hypotenuse. So I don't really care about the adjacent side because that one is not one of the sides we're dealing with. So if I write down so toa, which one of these am I going to be working with? Well, we've got opposite and we have hypotenuse, so that tells me I have to be using sine. The other two don't deal with opposite and hypotenuse at the same time. So to set this up, I'm going to do sine of the angle, which is 25 degrees, equals opposite divided by hypotenuse. It's really important. You always put sine of the angle, and then you say it equals that fraction that we come up with. So we did identify the two sides, done. Which trig function are we going to use? We said we're going to use sine. Boom. Set up the equation. We did that. Now we're going to solve using a calculator. So here's where the calculator comes in handy. We're going to have to type in sine of 25 into our calculator. And what I'm going to do is grab my calculator, and just a quick reminder, if you're using this graphing calculator, The one thing you have to make sure of is if we hit mode, it's right next to second there in the upper left, we have to make sure we're dealing with degrees, and it defaults to radians. We're not doing radians right now, we're dealing with degrees. So I'm going to move it over to degrees, hit enter. And if you're using an online calculator, you'll need to do this every time. If you're using an actual physical calculator, you just have to do it that one time and it should stay in degree mode. Okay, so I'm going to hit second mode to quit out of there. Then hit sine 25. And the sine of 25 degrees is 0.4226. So let's head back here. Sine of 25 is, whoops, let me grab the pen. 0.4226 equals x divided by 14. And then if I want to solve for x, we cancel out dividing by 14 by multiplying by 14. So back to my calculator, I'm going to take that and multiply by 14, and we get 5.92 approximately. So in this case, x is approximately 5.92. And that's it. So that's where the calculator comes in handy, is you have to use the calculator to identify the sine, cosine, or tangent. And then you just solve for x. And we got 5.92. Okay, let's set up the next one. So first, let's identify the sides. Here is our angle, is 58 degrees. So that's going to be our theta. And x is opposite. 9 is adjacent. The long one is the hypotenuse, but we're not dealing with that because that's not either the x or the 9. So let's do this. Let's write down our SOHCAHTOA. And which one of these deals with opposite and adjacent? So that would be tangent. So the way I set this up is tangent of 58 degrees. You always do the angle. You're doing the sine, cosine, or tangent of the angle equals opposite over adjacent. So x divided by 9. All right, so then go back to my calculator. Let's see, zoom out. So tangent of 58 degrees, and that is 1.6. And then since it's x divided by 9, I'm going to multiply by 9 on both sides. And what do we get? So times 9 is 14.4. So in this case, x is approximately 14.4. And that's it. So hopefully that makes some sense. We're identifying opposite, adjacent, hypotenuse. And then you have to say which one are we using, sine, cosine, or tangent. And then once we identify, we just use our calculator to solve for that missing side. All right, so that is it for the day 1 notes for Unit 6.